If we also think about the case for more openness, security research, historically they benefited from enormously. If you look at the entire field of cryptography, it really got stronger because people published attacks publicly, which kind of forced better designs.
All that and more on today's Mixture of Experts. I'm Tim Hwang, and welcome to Mixture of Experts. Each week, MOE brings together a group of the smartest minds and clearest thinkers working at the frontiers of artificial intelligence to banter, debate, and navigate their way through the week's news in the technology. On this week's episode, we've got Martin Keane, Master Inventor, Kaoutar Maghraoui, Principal Research Scientist, and we'll also have a special segment from Aaron Baughman, IBM Fellow and Master Inventor. Welcome to you all. Welcome back to the show. It's a packed episode, as always. I always love saying that, but it's also like some really big stories today. We're going to talk about the Wall Street Journal getting a hold of OpenAI and Anthropic's financials. A really interesting kind of fun experiment that someone did using AI in science. And as I said, Aaron will be on for a special segment talking a little bit about his work at the Masters. I wanted to start with what is arguably kind of the biggest story of the week, which is Anthropic's Project Glasswing. So rumors have been swirling for a little while that the next big great model for Anthropic is on the way, and it's going to be called Mythos. And it happened earlier this week that, Anthropic did announce and confirm that Mythos is their latest upcoming model. And reported some kind of shocking metrics about the ability for the model to perform SWE bench tasks, and most interestingly, sounded a note of alarm with regards to the capability for this model in identifying cybersecurity vulnerabilities. And so one really kind of weird outcome is that rather than releasing Mythos, they did an announcement saying we are not releasing Mythos, and with a coalition of partners, we're trying to make sort of the world safe for this model before we put it out. And so, Martin, I guess maybe I'll toss it to you first. Like, this is a little bit unusual. We don't usually have a whole lot of news when a lab decides not to release something, but that's the world we're in, apparently.
Yeah, this is completely different to any other major model release. I mean, if we think of how this usually goes, a lab has a new model and they want everybody out there using it and to build up as much hype about that as possible. So Twitter influencers will be given access to the model a couple of weeks early. People will be running benchmarks. We'll get to see some output from the model, something impressive looking visually that the model's been able to generate. And this is a completely different approach. And the other thing that makes it so different is this is the first time we are focusing a model on cybersecurity and its capabilities there, rather than the more traditional stuff, which is, how much better it is at coding this and creating things. It's basically saying this model is so powerful, it can basically hack into any existing software. It's going to find all sorts of vulnerabilities. We can't release it out to the general public yet.
Kat, I wanted to turn to you because I agree the cybersecurity story is kind of the most interesting part of this in some ways. And I mean, I just want to read one of the quotes. They had a representative from Cisco say this, quote, "AI capabilities have crossed a threshold that fundamentally changes the urgency required to protect critical infrastructure from cyber threats, and there is no going back." That's a pretty big claim from, a company that's like Cisco is like a long history in enterprise. They are like sober players in the game. But you have this SVP, right, Chief Security Officer, saying that this model really changes the game. And I guess, Kaoutar, for you, I guess the question is like in the realm of cyber, whether or not you feel like now, suddenly like offense has the advantage. If you have one of these models, you can hack into any computer and there's really not that much we can do to defend against it.
Yeah, I think I have a little different take, compared to what Martin said. Of course, there is a marketing aspect to this, but I think this project is genuinely unprecedented. And the decision not to release publicly, I think deserves to be taken seriously than just, dismissed as marketing caution here. Because if you look at some of the things that this model was capable of doing, the examples that they were showing, they're pretty, scary examples. Like the 27-year vulnerability bug, the OpenBSD bug, that Mythos found, which is a flaw that was present since 1999 that crashes any OpenBSD server. The 16-year, also age of the FFmpeg, vulnerability, which also was in a line of code that many automated tools, hit 5 million times without even flagging. So there were some really deeper insights, that we got from here. And also the sandbox escape incident, where the model acted in an autonomous way, in ways researchers did not even, request, including even communicating, with the outside world. All of these things suggest that we're dealing with capabilities, like, the Cisco SVP mentioned, they operate at the edge of current interpretability and control methods. But I think also there is a deeper systems insight here, which I feel the asymmetry between the offense and defense in software security has always been structural. Attackers need to find one vulnerability and defenders need to eliminate all of them. But what happens with AI? AI dramatically amplifies the attacker's surface. It amplifies the attacker's side of this asymmetry. And I think this project is kind of an attempt to use the same capability amplification on the defensive side, because it requires here defenders to move fast and to also not just fast, they have to move first. So, and I think these are very important implications for the safety. So, like, for example, if you look at the EU AI Act's next compliance phase, which I think would take effect around, August 2026, automated audit trails on cybersecurity requirements for high-risk AI systems are really now kind of legally mandated, not optional. And I think Glasswing is really arriving at exactly the moment regulators are demanding governance infrastructure. So I think it's interesting to watch how the compliance and the offensive capability stories intersect over the next maybe 18 months. It's going to be interesting to watch.
Yeah, for sure. I guess, Martin, it's worrisome what Kaoutar just said, right? Like, is it like, do I need to be buying, gold bars, moving everything to YubiKeys, like how paranoid should we be, you think, as a consumer on this tech? Obviously they're not releasing Mythos to the world, but these capabilities are coming. And so on on a certain level, I'm kind of like, how much time do I have to really up my personal security here? Is that how we should be thinking about it? Like, if you're a listener of this show, are you kind of like, stop everything, go to the next level of security across the board personally?
Yeah, I think the clue is in the name. Mythos, meaning mythology. And most of us are just going to have to kind of guess what it can do until we get access, because we're not in Project Glasswing necessarily.
Yeah.
So, yeah, that's a very fair point. And it does seem from the initial studies that this has found all sorts of vulnerabilities here, as Kaoutar was saying. And it just, what else is out there? The things that we have been using, taking for granted as somewhat secure at this point, are they going to continue to work? And we don't have very much information to go on right now. So the outcome of this is going to be really interesting, once this preview period is over, because Anthropic haven't said what's going to happen after the preview period. Is it going to be generally available after that? We don't know. But just to see what this model is able to find. So what we've got to go on currently is what's in the system card. And also, presumably, this is the model that Anthropic have been using internally to develop their own software up until now. If we think of what Anthropic have been releasing over the last month, they basically went through an insane period of about 30 days where every day there was a significant update to Claude and the Claude app and what it can do. And, people are starting to scratch their heads. How is this possible? How are they able to get so many features in? Have they actually got this sort of recursive improvement model now? What is doing this? And I think we know now the answer to this is it was using Mythos. Interestingly, though, the Claude app, which I use extensively and I think is amazing, is absolutely filled with bugs. So is Mythos not finding those bugs? I don't know. Is it just good at finding security vulnerabilities? So yeah, the answer is we just don't know if we need to be, emptying our bank accounts and putting everything under the sofa or not.
Yeah, I think that's right. For what it's worth, I have not emptied my bank account and converted it into gold or anything just yet, for what it's worth. Kaoutar, there's a really interesting question here because I think Anthropic's really made a choice in some ways in how it's approaching the security problem, right? They say, we've got this incredible new capability. The best way of making these models safe is we're going to create a small consortium of companies that are going to work to make kind of the world safer before we maybe release the model. I think Martin's already kind of reflecting some of this, which is that like we have no idea from the outside what's going on here. And it's very hard to kind of like evaluate, what is the security improvement being made or even what the risk is exactly. And so I guess, Kaoutar, if you've got any thoughts before we move on to the next topic on sort of like, how do you think companies should balance this? Is it balance really between open and closed, right? What makes the world more safe when it comes to these models that really do genuinely seem to have like some pretty next generation capabilities?
Yeah, I think that's a very good question. And I also want to point here to maybe the core argument that Anthropic was given here for the consortium. Like why this consortium model is even, temporal for now. So I don't think they want this to be a permanent thing that we keep it closed. Eventually, they want to open it because, capabilities like Mythos preview, they will proliferate regardless. Other frontier models are close behind. Like, for example, when OpenAI released GPT 5.3 Codex in February, and we discussed it, it was the first model they classified as really high capability for cybersecurity and their framework. Anthropic believes it's not at most a 1 to 2 year window before even Meta's class capabilities are broadly available. So I think what's the move here is particularly, I think the organization responsible for the most critical global infrastructure, they need to have access to these models first, kind of giving defenders, it's kind of a bet that giving defenders a head start with the model is better than waiting for safeguards to be perfect. So the plan is to develop those safeguards with kind of an upcoming Claude Opus model, which carries lower risk than Mythos, and then progressively expand access as the safety framework matures. Because before giving it to everybody, let's test it. Let's put some safeguard. Let's have the people, especially responsible, all these organizations responsible for the really critical global infrastructure, work with it to kind of test the waters before we open it. Because again, as I mentioned earlier, this is really giving the offenders a much bigger surface to work with, and this is pretty dangerous.
Yeah, I mean, it's exactly as we're saying here that currently Mythos, they have the benchmarks to prove that this is the smartest model that is able to find things that other models cannot. That is a very temporal point in time statement that other models will also be there, and not just necessarily models from the frontier labs. Again, if we look at the progress of, think back to GPT-4. GPT-4 came out and it was way above all other models, and now a 3 billion parameter open source model is as good as GPT-4. So open source models are coming, probably something like 9 months behind, something like that, where the frontier models are, that will be able to find some of these vulnerabilities as well. So this is something that we have to prepare for. We can't just think that a small consortium of companies, great for them, they'll be able to find their vulnerabilities first. But this is going to be available to everybody, including bad actors. And we need to be prepared for that.
I think maybe this, the question that you have is maybe a hard question here, because I don't think there is a clean answer. Because what Anthropic is doing here, it's kind of in the middle. It's not binary. It's not like, no, we're not going to give access to it. So they didn't keep it entirely closed either. So they didn't release it. But, they gave access to a curated consortium under controlled conditions. And, if we also think about the case for more openness, security research, historically, they benefited enormously from these open publications and open research. So if you look at the entire field of cryptography, it really got stronger because people published attacks publicly, which kind of forced better designs. So there's also a counter argument here. If only 12 large companies have access, the open source maintainers with maybe a 2-person team still has nothing, right? So it is kind of a tension here. So the consortium model might have here some weakness because, it only concentrates the defensive capabilities in exactly the organizations that are already best resourced, like AWS, Google, Microsoft, etc. But and the open source maintainers are actually they only get indirect benefit from kind of these 4 million, in donations to the Linux foundations and Apache, which is kind of a rounding error compared to the 100 million in model credits going to trillion-dollar companies. So what's the right balance? I think the right line is probably around findings versus capabilities. So because the vulnerability findings, especially the specific bugs discovered, the patches, etc., I think they should be shared openly and quickly as soon as possible. And that's what kind of protects the internet directly. The model itself, and especially the autonomous kind of exploit generation capabilities, they kind of warrant continued restrictions until maybe interpretability and control research catches up. So, so I think my take is open the findings, restrict the weapon here. The bug reports should be public, but the autonomous exploit here, the generator probabilities, etc., probably they shouldn't be yet.
Well, we'll keep an eye on it. As Martin, you said, we don't really know where this is going to end up. So it's going to be a big experiment, and we'll see kind of where it lands in the end. All right, I'm going to move us on to our next topic. Some really interesting numbers coming out of the Wall Street Journal. They basically got a hold of some of the financial numbers for OpenAI and Anthropic. And I think the most interesting sort of aspect of this is just the kind of scale of what's happening. Both companies are growing at an incredible rate. But I think one of the most interesting things about it is just the degree to which Anthropic, despite being a smaller company and having a much smaller footprint, Claude having a much smaller footprint than ChatGPT, is making a huge amount of money. And it really kind of suggests that there's kind of going to be these two paths in frontier AI. One will be really fully enterprise, and the other one will be sort of like fully consumer. And I guess question to you, Martin, is like, do you think that's kind of how you see these lanes settling over time?
Yeah, well, I mean, that has been the division primarily in that ChatGPT has a hugely larger consumer business than Anthropic. But we've seen in the last couple of weeks, basically OpenAI talk about flipping that entirely to become much more enterprise focused. And just looking at the revenue today, I mean, Anthropic's revenue is almost entirely from enterprise, and the majority of revenue for OpenAI comes from consumer. It comes from people paying their monthly subscriptions. And clearly they see that actually enterprise is going to be the way to go as well. So they, this has been a topic on previous episodes here. We talked about how things like Sora are going away and other sort of consumer-facing content out of OpenAI saying we need to focus our compute on enterprise use cases, and that's not an enterprise use case. So it seems that actually, although Anthropic is a smaller company in terms of revenue generated, OpenAI, the much bigger company, are actually looking at replicating their strategy and moving toward the enterprise as well, which potentially leaves a whole untapped market for consumer stuff from somewhere else. The ChatGPT has just absolutely had that area nailed down. Maybe somebody else will get a chance now.
I guess, Kaoutar, how bullish are you on the kind of consumer part of all this? Because I think that's kind of like the question being asked here is, as everybody kind of converges towards enterprise is where the money is there room for a consumer company? Or maybe actually are we finding that kind of consumer AI is actually not that big of a business?
Yeah, I think that's a very good question here. I think I feel there is a real strategic divide here, like enterprise versus consumer. Because Anthropic, like if you look at the examples of Anthropic and OpenAI, Anthropic never had a consumer face. From the beginning, it was built, for enterprise API contracts and cloud provider deals. And the results, we can see them visible. 80% of Anthropic's revenue, it comes from business customers. And 8 of the Fortune 10 are cloud customers. Over 500 companies, spend more than $1 million annually just with Anthropic. OpenAI, on the other side, they have like more than 90 million plus weekly active ChatGPT users. Anthropic, if you look at their share, it's only 5% of that consumer reach. So Anthropic just kind of passed OpenAI on the top line run rate anyway, even if they don't have, kind 5% of that consumer reach. If you look here, consumer scale and revenue scale are not the same thing. Enterprise contracts basically carry higher retention, better expansion economics, as we've seen with Anthropic, and even lower churn. So the company that basically was enterprise first from day one, we can see it's pulling ahead as a result of this. So these are kind of different strategies, and the question is, which one is going to win the race, or are we going to be in a hybrid model? I think maybe instead of focusing on that, the economics are very important, because the cost equation here, you can see that the financials that reveal, that we can see here, Frontier AI, they've structurally kind of broken kind of the SaaS economics models. Because in software in general, the marginal cost of serving another user kind of approaches zero as the scale grows here. But in AI, what you see is the opposite is true. Inference cost grows proportionally with adoption, and every new user is another burden on the data center. So I think what the real battle here is not about maybe how well the model or consumer versus enterprise. It's more about the cost per token at inference time. And I think whoever solves that hardware-software issue, which I feel it's a hardware-software co-design for inference, things like the memory efficiency, the operator fuser, what architectures are we using, data flow, for example, especially all of those tricks and algorithms that eliminate redundant data movement. I think whoever solves that well kind of will define the unit economics of this industry. Because if you look, training in general, it gets you the headlines, but really inference is what wins the business, because that's the continuous thing that you have to constantly, operate.
The inference numbers are pretty interesting here, right? Which is that right now, I think the stats are that they're still eating about half of the revenue at both labs, but the share is sort of declining over time. And so I guess the question is whether or not that's going to eventually settle out as like, well, about half of your revenue always gets eaten, by inference, or if there will be some breakthrough that kind of like allows you to drop that significantly. Seems to be a really big question in like how far this kind of business can go. Yeah. Martin, I think the other thing I want to talk a little bit about is also just the sheer rate of growth. So Lenny Rachitsky, who is a blogger on kind of tech and product, just posted, I think, yesterday that Anthropic's actually now up to 30 billion ARR. And that's up from 19 billion in February, right? Which is like a crazy add. They added 11 billion in ARR in 1 month, which is really kind of unprecedented in some ways. And I look at that and I'm like, how much further can this go? Because these numbers are insane in the same way that like NVIDIA numbers are insane, where you're like, oh, it's going to be worth about $1 trillion. Why would what even is numbers anymore? And so I guess the question I have for you, Martin, is kind of like how long do you think this growth will be sustained? Are we just at the beginning? Are we kind of halfway through? It's really hard to judge, but curious about how you think about that.
Yeah, I mean, it seems from looking at this Wall Street Journal report that there are two essential costs here, of course: inference, which is running the models you already have, and then the development of creating new models. And we're talking about ways here, Kaoutar's talking about ways here that we can reduce potentially inference costs by having more efficient models. But at the same time, new models are not getting any smaller. They're getting much, much bigger. So even if you didn't do anything to make inference more efficient, just the fact that models are getting bigger and bigger are costing more and more, they are going to eat up a larger percentage of revenue than inference over time. And that's what this report shows. I mean, there's just some fascinating numbers in here. Like, Tim, it's exactly like you say with, NVIDIA, just like...
What even are numbers?
Right, yeah. These are numbers apparently, and they just bear no sort of resemblance to previous reality. But so OpenAI projecting that in 2028, they will be making 121 billion in revenue, which will result in a loss of $85 billion. I mean, a company losing $85 billion in a year is absolutely insane. And that assumes, by the way, that they will double revenue in that time. So double the revenue will result in an $85 billion loss. And why is that? That's because the cost of training new models is so high. Now, if you took today's numbers and you took out model development, then both Anthropic and OpenAI are probably turning a small profit. And OpenAI, in fact, offer a set of accounting reports that have compute for research, which is model development, taken out. Because we're just not going to count the R&D stuff. But the R&D stuff is the absolutely massive part here that makes such a big difference, and it's just going to, become more and more as models get bigger and bigger. So there's really two areas for efficiency here. One is, can we take the existing models and run them more efficiently? There seems to be a lot of work that is in that area that is improving inference costs to some extent. But are we ever going to get to a point where the models are not more and more expensive they're exponentially more expensive with each generation to build?
Yeah, it's actually, I never thought about that like that, but I do really it's like almost a race between your inference efficiencies and the scale at which you need to build new models, basically. And like the two, it's a question of which one is going to outweigh the other over time. But I think the bet is because every model gets bigger and bigger and bigger, eventually that one outweighs any effect you get, unless there's a real radical change in inference. All right, for our next segment, there was this kind of fun story. We've been talking a little bit about, world-ending cybersecurity issues and spending billions and billions of dollars. But I think some of my favorite stories in AI are really kind of just small experiments that people are working on. And there's a guy by the name of Michael Hia who had this post that went semi-viral online, but I found it to be a really interesting experiment. He basically created something he called GPT 1900. And what he's trying to do is answer the question of whether or not AIs are good at doing scientific discovery. And, one way we can do that is to take all the facts we have right now and see whether or not AIs can make discoveries today. The other way we can do that is basically to reset the clock for AIs, to basically give them all the facts that scientists would have in, say, 1900, and see if they can sort of redevelop concepts that we already have discovered today. And this is just such a very compelling kind of experiment. And I guess, Mario, maybe I'll kick it over to you. I'm curious about your reaction to this and whether or not it is a good way to get some intuitions about whether or not AIs really will be kind of advancing sort of the state of scientific inquiry in the future.
Right. I mean, it comes down to this fundamental thing of, can AI generate new knowledge, or is it just pattern matching? And in this case, this is a task that potentially is really just pattern matching, in that all of the information you need to make these scientific breakthroughs is potentially in the training data that the model is given. So is it smart enough to be able to connect the dots to actually come up independently with those discoveries? And it was so interesting, such an interesting experiment. And unfortunately, there wasn't really a definitive yes or no
yeah.
here. For example, when it was asked questions like, how can gravity bend light when light has no mass? It came up with some kind of 19th century answer about talking about ethers and surrounding the light beams and stuff like that. Probably if you went down deeper, it would talk you about bloodletting and foul air as well. So it's a super interesting experiment. I mean, I think there are two things that I would say means it's probably not going to work. One is, what sort of test time compute did the model have to come up with these answers? If I'm asking it about how gravity bends light, am I just putting that into a chatbot interface and getting an answer back? If I'm trying to independently discover the theory of relativity, am I thinking for 5 whole minutes on this through the model, or what? I mean, I think Einstein had a little bit longer to come up with these things, to actually think through everything, to perform experiments, versus whatever reasoning stage is.
Yeah, you're saying it's like an unfair
model.
test to the AI. We're not giving it all the time it needs to think through these problems.
That's right, exactly.
Yeah.
And the second thing is, the model that they ended up building, the GPT 1900 model, pretty small model. It was about 3 billion parameters. And what we know about small models is that in pretty much every domain, they are less smart than big, large frontier models, even in the domain that they are trained on. So we think back, there was a period of time where people were kind of training their own large language models to perform specialized tasks. So, for example, Bloomberg created their own large language model trained entirely on Bloomberg data. There were legal LLM models trained entirely just on legal stuff. And it turns out that their performance were worse at those tasks than just a general purpose model, because a general purpose model with more parameters is smarter at everything. So in this case, we're comparing a model that's 3 billion parameters to, not to a frontier model, but to like Einstein and Newton, people like that, right? So what chance did it have? But super interesting experiment. And I'd love to see this taken a bit further.
Yeah. Kaoutar feels like maybe this is like, it's sort of notional more than it is actually kind of like research. I guess if you really want to kind of chase after this, you would want to deploy like Mythos against all the scientific literature available to that point or something like that. I do think that one of the intuitions that I got, at least from the results that this guy Michael showed, I guess was the degree to which like I feel like a lot of the models are still in the kind of paradigm exploitation mode, right? So at no time in his experimentation did the model come up and say theory of relativity, though it created a lot of things that were maybe like suggestively close to it. And so it still kind of feels like maybe the advantage for like a true kind of unexpected breakthrough, is maybe still advantage humans. But I guess Kaoutar, question to you is whether or not you think that's like long to stay.
Yeah, so I think there needs to be more things to really get to that stage when AI can really do real science the way that humans traditionally has done it. And I'd like maybe here to bring the perspective of, Thomas Cohen. He's he's the philosopher and the historian of science whose 1962 book, The Structure of Scientific Revolutions, is one of the most cited academic works of the 20th century. And I think generally one of the most useful frameworks of thinking about AI from my perspective, what AI can and cannot do in science. Because I think if we look at his perspective, he distinguished between two things. The normal science, which is the puzzle solving within an already accepted paradigm, and the revolutionary science, that's kind of the rare moments when you have the paradigm itself is replaced. Like you really kind of have groundbreaking results. You're creating completely new paradigms. And of course, what the study is also reinforcing this, the current AI systems, they're really good at the former. Basically, kind of puzzle solving within accepted things, but they're struggling with the, kind of creating new paradigms. And what we're seeing, the model, of course, can reconstruct reasoning chains that lead, toward maybe relativity, but it struggles to produce the key conceptual move here, kind of reconceiving, things as relative or completely, opening new grounds. So, and of course, it's just, it's not pattern recognition per se, but kind of willing to discard kind of the dominant ontological frameworks, something kind of that runs really against the grain of a system trained to predict the model, what's the most likely next token. So, but if we can see, there are, some frontier models that are already doing real science. I don't know if you're familiar with what OpenAI published about GPT 5.2, that it had derived a new result in theoretical physics, which is this general formula for gluon scattering amplitudes that human physicists had been unable to spot despite basically computing specific cases for many decades. And, what's interesting here, of course, this is not paradigm creating in the true Cohen sense, but it is something else. It's more kind of a systematic exploration of mathematical spaces that are maybe too large for human intuition. So the model here did not break a new paradigm, but it found a structural regularity hiding inside an existing one that humans had missed.
Yeah, and it's almost like the old adage of like, oh, once an AI can do it, it's not really AI. It feels like almost like it's like once the AI discovers it, it's just pattern matching, right? Like, oh, we
Exactly,
could have
yeah.
done that if we had all the facts.
Yeah, but we just missed
is
it
sort of like,
because it was such a complex system.
that's right.
But I feel like for scientific discovery, it's not really a retrieval problem. It really requires generating hypotheses, testing them against reality, including unexpected experimental results, iterate, revise the model, basically the world, right? And what LLMs do, they operate on a fixed corpus, so they can synthesize and reason over what was written, but they cannot be surprised by new data in the way a scientist must be. So it feels like really the path forward is to have kind of these closed loop. So because the bottleneck here is not model intelligence, it's the absence of having this feedback loop between the language model reasoning and the experimental or simulation infrastructure. So I think the models that really will transform science, they're not the ones that score maybe highest on GPQA Diamond, for example. They're the ones that maybe integrate into the laboratory workflow. So once I think we get to that stage when models are using this feedback loop, then maybe, we'll see different results.
Yeah, and Kaoutar, something you said there about the model needing to think outside of orthodoxy, basically, of not thinking the same way as currently thought. I mean, if you think about how most scientific breakthroughs have occurred, it's often somebody who's a bit of a maverick, who's thinking in a way that is outside of the orthodox way of thinking, that thinking something completely different, and basically initially meeting a lot of resistance and being told that they're completely wrong. Turns out they weren't. And that's not really how large language models operate today. In fact, that's the complete opposite of it. So I think we need like a maverick GPT out there that will be able to do some of this.
Yeah, that's well said. Basically, LLMs, they compress the knowledge. They do not yet create it. And I think that distinction is really important of how we instrument and integrate these systems in research environments.
Mara, maybe less a final thought here. I think a little bit about like where else this can go, right? Like let's give a model all the paintings in 1900. Like, is it eventually going to invent, expressionism or something like that? Do you think that there's kind of a similar paradigm here, or are we talking very different things when we move from, say, physics to the arts?
Yeah, I really don't know. Like, is the path that we have taken as humans the inevitable path that would have happened no matter what? And it's just, that's the obvious way that it would have gone. Or, in fact, is that just one of many, many different paths that could have been taken, and we just happened to go down that one, and now looking back, it seems obvious that that's the way to go, kind of thing. So, we're getting into sort of parallel worlds here of
Yeah, exactly.
potential outcomes that we could run, and if we could build these models and run them enough times and kind of see where things would end up based on that, that would be a pretty fascinating experiment.
That would be pretty cool.
Each one is in a parallel world.
Yeah, exactly.
And
Like, how long till we get the
simulating
AI
parallel
Einstein?
universes.
Is it this year or this year? So
Interesting.
Well, this has been a super good discussion as always. Kaoutar, Martin, it's great having you on the show. Hopefully we'll have you on soon. And I'm going to move us on to our next segment, which was pre-recorded with Aaron Baughman. I'm super, super excited that we actually have a bonus segment today. We've got Aaron Baughman, master inventor. He'll be well known to regular listeners on the pod. Aaron, welcome to the show. I know you're here to demo some of the work that you've been doing with the masters recently.
Yeah, so it's great to be here, and thanks for having me, Tim.
Well, so tell me a little bit more. Every time we have you on the show, I know you're working with a different league, a different sport, a different event. This one seems like you're going back into the world of golf. And what's the project that you're working on today?
Yeah, so this one's very interesting. If you think about it, over the years, the Masters, which is one of the golf majors here, it's accumulated this large archive of rich video content. It's really decades of historical shots and these unforgettable moments that's happened over the years, and these legendary performances. But here's the challenge, right? That despite its value of having all of this video content, it's very unstructured and it's hard to search, right? And define exactly what you're looking for. And to really build on top of that, there's hundreds of hours of broadcast footage. There's no easy way, right, to search for these specific moments in golf that happened at the Masters in the past. Video is an index in a way that reflects really how fans think or want to query. And then context, as you think about it, like player shots and different outcomes, it's really buried inside the footage. So even though the content exists, it's truly not accessible. And that's where this project comes in, right? It's called Master's Vault, right? And the goal is very simple, right? But it's also powerful, right? We want to do two things. One is to automatically extract, label, and index, these meaningful content that's within this video. And then the second part is that we want to begin to enable users to be able to search with natural language, how to find this content. And we had really started out with two hypotheses, so we weren't exactly sure how we were going to tackle this problem. But the first one is that if we can accurately process these broadcast graphics and commentation and understand the scene and golf stats, then users will be able to find, search both very precisely and broadly to find these kinds of moments, right? And then the second hypothesis that we had and wanted to test is that by summarizing and fusing these meta tags that we pulled out, that we could reduce the redundancy of data, we can improve the understanding, and really deliver more accurate search results. So really, at its core, it's this multimodal AI system, right? And it combines vision, audio, and language together so that people can retrieve information. And we're talking about 58 years, right, of full-length broadcast videos, and that goes to several hundred hours, right, of curated footage. And that's a massive data set, but it's also a massive opportunity here.
Yeah, definitely. And now, Aaron, I know you're going to show us a quick demo of what you've built, but one thing I always enjoy when you are on the show is you tell us a little bit about, some of the technical challenges that you had. These are big projects. Video files are really chunky. But I'm kind of curious if there's anything that you learned or any particular kind of sort of challenges you ran into doing a project of this scale.
Yeah, so I mean, there were certainly a few, and I'll touch on a few of the highlights here. One would be the evolving broadcast graphics, right? Because broadcast graphics have changed dramatically over time, right? So if we look in the 1960s, and I watched some of the videos, but they have physical models of the course, and they manually manage scoreboards, right? And they had minimal on-screen graphics, right? But today, if you look at it, it's fully digitized. There's shot tracking. We have 3D models of the course. There's advanced analytics and insights now, right? And the system, it must understand really all eras, right, of this broadcast formats, which is extremely hard. The second part would be, I would say, commentary ambiguity, right? Where commentators, they often reference past shots, even though they're talking about a current shot, right? And then also you can have a current clip. It might include commentation about a previous shot or even a previous year shot, right? And this could lead to false retrievals if we don't handle that right. And then I would say the third part of this would be video quality variability, right? Older footage, it's really fuzzy, it's low res, right? Then if you go to like 2016, we had partial 4K. 2018, there's 4K HDR, right, on some select holes, and we're even starting to look at 8K now. But all of these models, they must handle this inconsistent visual quality right across the gamut of these years. And even though the broadcast graphics have evolved from showing the score, we're now what we're trying to do is to explain the game with this kind of project here.
Well, do you want to show us what you built? Would love to see it and show it to our listeners here.
Yeah. So, would love to. So, let me just walk you through a couple of demos. First off, go to www.masters.com, and you can go through the main menu and find the Masters Vault. From there, if you create an account and log in, then you can have access to this really interesting and powerful system. So, first, let's do a very broad search here, right? So, if I just want to find Bubba Watson, for example, I'll just simply type his name. You can also misspell his name. You can type in first or last name, right? And we handle all of that. So I'm going to go ahead and search. And then you see the search results come back. So the closest search results for Bubba Watson, what we do is we extract, right, every single shot, right, from the broadcast footage of the final rounds, right? And then you can see I can scroll down and we've broken it out by the hole and the shot number. And all of this text, it was generated with Gen AI techniques. So that's pretty cool. Now, if I want to go in and refine this, so let's do Bubba Watson, and let's search on shot 2. So we're getting a little more specific. And you'll notice that now we have Bubba Watson, and they're all shot 2s, right? So it's successfully pulled out just that shot here. But what if we wanted to even get, even a much more granular, precise type search? Let's do Bubba Watson, let's say shot 2 year, um, let's do year 2019, right? Since that's the second hit, let's just pick that one. So here you can see it successfully pulled out 2019 shot 2, right? And if I really wanted to, I could even go to like a hole, right? And that's neat too, I see. Um, but also what I want to show you now is that we do understand, or our system does understand the scene itself, right? So if I want to do Bubba Watson and let's do from the bunker, right? So this has a lot of implications. First, I got to find Bubba Watson, but then I got to find the scene that has a bunker shot, right? Which isn't easy to do, right? And you saw how fast that was, right? I mean, it almost instantly came back, right, after I typed that in. So it's pretty neat. And you'll notice that we have 2 shots that we pulled out of the broadcast, just again, final round broadcast. So if I click on this one, let's just, prove it out and show you that this is from the bunker here. So
16.
Out of the bunker, Bubba Watson.
right, so you can see the ball, right, and all the sand that's scattered across the green.
Now watch.
Right, so we detected all of that sand play. Right, so let's stop that. And then I also want to show you the second hit that happened here.
Get it past the hole.
So
not
this is
6 feet
clearly
wide.
another
That's
bunker
two.
shot. So we got it
Unusual
right here.
happening there, Nick.
Right, so there weren't any false positives, and it's
Popping it
very
into the
very
bunker.
precise and accurate there. Let's do another one. So lots of people want to know outcomes. All right, so these outcome based searches. So if I do Bubba Watson and let's type in eagle. So let's see, again, very fast, came back fast. We're very proud of the speed and the precision because lots of times it's a trade-off between the two. And let's just pick this one here. And, how do we know it's an eagle? Well, you can see in the scorecard, it's referencing eagle, right? But that's a historical part. So that could be very confusing, right, for a model. But if I play the actual clip, right, where it came from, there you go.
Now we saw the
For eagle. So Bubba
second
Watson is
shot
going for
Bubba.
eagle.
This
Right, and let's see if he makes it. Great. So
eagle,
he made it. So he
that's
actually
two
made
today.
the eagle.
the second hole.
So we got the outcome right, and we were able to parse the graphics correctly, right, from the video itself, right? And we do this for, over hundreds of hours of videos that we process, right, and detect that. Now, I also want to show you something interesting too that I find nice. So if I do a broad search, let's do Bubba Watson, and let's go back to 2019 only. Okay, so we have 2019 here. So let's click on this here and play it. All right, so let me pause it. So you notice all these little yellow markers here, right, on the play track. This means that these are all hits, right, within this broadcast stream, right? So we not only can find the exact hit and search that you search for, but if you wanted to, you could go and click on any place in this playlist, right? I won't call it a playlist, but a streaming M3U8 file here, right? And then boom, play it, right? And you can jump back and forth, right? So that's nice, right? That we're able to do that. I would encourage you to go and play around and enjoy, the Vault. You can do any permutation of the searches I just did. You can search on any golfer, right? Just keep in mind it's round 4, right? And this is the streaming broadcast that you would normally see on TV, right? And what we're doing here is we're transforming the video, right, from static media, right, into searchable and intelligent knowledge systems. So I think in short, when we combine vision, sound, data, and language, you're not just watching history, but now you can query and search it. So I hope that you enjoy it and give us some feedback as well.
That's awesome. Thanks, Aaron, for presenting, and thanks for coming to the show as always. You guys should all check it out. We'll put the link in the notes. And Aaron, we'll hope to see you very soon here on the show.
All right. Thanks so much, Tim. Appreciate it.
And that's all the time that we have for today. Thanks for joining us as always. If you enjoyed what you heard, you can get us on Apple Podcasts, Spotify, and podcast platforms everywhere. And we'll see you all next week on Mixture of Experts.